welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today we're going to talk about rocketry and then you can build and launch straw rockets. Are you ready to get started? Let's go! First, let's talk about how a rocket works. A hot gas is pushed out of the rocket's nozzle at such a high speed and force that the rocket is pushed forward and upward. A rocket is a hollow cavity keeping a gas under pressure. Inside the rocket's engine, when the fuel is burned, it causes the gas to heat up. A small opening at one end allows the gas to escape in one direction, providing thrust. Thrust allows this force to overtake gravity and propel the rocket skyward. This is an explanation of Newton's third law of motion, which states that for every action there is an equal and opposite reaction. The action, the rocket pushes the gases down, and the reaction, the gases push the rocket up. Most historians believe that rockets were invented by the Chinese around the 11th century. By the 13th century, rockets spread to the Middle East. They were known as fire arrows. Early rockets were tubes stuffed with gunpowder. When ignited, the gunpowder exploded and produced hot gases that pushed the tube. Eventually, the use of rockets spread worldwide for warfare and entertainment like fireworks. We have a better understanding of rocketry over the last 300 years because of Sir Isaac Newton. What have you learned about his laws of motion that will help you explain rocketry? His first law teaches us, for a rocket to lift off the launch pad, force must be exerted to unbalance the other forces. His second law teaches that the rate at which the rocket leaves the pad will be determined by its mass, fuel, and the force of the fuel being burned. His third law teaches that the motion of the rocket away from the launch pad is equal and opposite to the thrust of the engine. The straw rockets we will experiment with today work in the same way, but instead of using hot gases, we will use air pressure from our launchers. Think of catching a speeding baseball. To stop the baseball, you'll have to push back on it to bring it to a halt. You can feel this force in your hands and your arm as you catch the ball. Now, if you want to throw the ball back in the direction it came from, you have to exert even more of a force. First, you have to stop the ball, and then you have to speed it up in the other direction. Either way, to change the ball's motion, you have to exert a force, a push, on it. A rocket works based on this same idea. Inside a rocket engine, we have a lot of hot gases from burning the rocket's fuel. We can push these gases out of the back of the rocket by exerting a force on them. Let's talk about the most important parts of the rockets we will build. We will need the rocket body, sometimes called a body tube and sometimes called the fuselage. The body holds the propellant, a combination of fuel and a chemical similar to oxygen, and the rocket engine. We will also need a nose cone. The nose cone should have a rounded shape to minimize friction. This is where the cargo is, sometimes called the payload. This can be astronauts, satellites, or other materials. Our rockets also need fins. Airplanes have wings, but rockets have fins. Fins keep the rocket stable and flying straight. As the designer and engineer, you will need to consider the size, shape, number, and placement of your fins, but they're almost always at the rear of the rocket. The addition of fins to the rockets helps give it stability. As air flows over the rocket, it exerts a force on anything which it touches. The parts of the rocket with the most area feel the strongest forces because there is more surface for the air to push against. By adding fins to a rocket, we are increasing the area at the bottom of the rocket. This means that if the rocket starts to waver off course, the wind flowing past will hit its fins and straighten it out. How will this work? Well, the launcher shoots a jet of air out of the launch tube. This jet of air travels up into the rocket, but since the rocket is sealed at the top by the nose cone, the air is deflected and sent racing back in the other direction. Since the direction of motion of the air changes, we know that we are exerting a force on it, and since the rocket exerts a force on the air must exert a force on the rocket. Thus, the rocket feels a thrust upwards and flies off of the stand. You will be launching in groups of 4. One person in each group will need to be the safety officer. Your job is to make sure each launch is safe. Before the launch, the safety officer must make sure the field is clear and that no one is in the way of getting hit. Another person will be the launch officer. Your job is to make sure the launcher edge is straight against the tape on the floor and to make sure the launch rod is released, not forced or slammed. Then we need a measurement officer. Your job is to measure the distance that the rocket has traveled and report that information to the student that launched it. Lastly, we need an information officer. Your job is to make sure that students in your group are reminded to record their data after each launch on their own paper. You should also watch for variables that might throw off the experiment and make sure that each student tests their rocket 3 times. Teachers will pause while you create those groups. Now we need to build our rockets. Your teacher has all of the materials you need and the direction sheets to guide you through each step. But before you start to make your own, let me show you a few things. When you get your clay, knead it to soften it and carefully shape the clay. You'll need a piece of clay around the size of a grape to begin with. Using the digital scale, weigh the clay and record it on your data sheet. You should start with a piece that weighs 3 to 5 ounces. Press the clay onto your straw and shape it into a nose cone. Let's all make them pointed for the first test, like the pencil erasers you can add to the end of your pencil. We can try other shapes and weights later as different variables. Make sure that the clay is solidly attached to the straw and makes a good seal. I suggest that some of the clay go into the straw. This will help it stay on. The outside edge between the straw and the nose cone should be sealed carefully with the clay, so I pull it down a little bit. Your next step is to draw your fin shape on an index card. You can use the template included. Rockets normally have 2 to 4 fins. Let's all make them triangles at first. We can try other shapes later as different variables. We can try different numbers later as variables too. Using scissors, cut out the fins. Tape the fins onto the bottom of the rocket, opposite from the nose cone, trying to space them evenly around the rocket's circumference. Use a piece of tape the length of the edge of the fin to connect it to the rocket body. Place the tape on the edge of one fin and then repeat this for all of the fins. Attach the fins so they're evenly spaced around the straw. Do not have any excess tape hanging off of your rocket. Teachers, as your students are making their rockets, you can be setting up the rocket launchers. Launchers are known to shift a little, so if you put a piece of tape on the floor, the students can line it up in the same place for every launch. You may also want to make sure they are designing fins that are all the same shape and size and mounting them in a logical arrangement on the rocket. We'll pause here while you make your rockets, and we'll talk again before you launch. Okay, before you get started, let me give you some tips on using the launcher successfully. First, make sure the launchers are on flat and solid surfaces. Adjust the angle of the launch tube to the desired degree mark. Place your rocket on the launch tube. Carefully move it and the rocket back in line with the desired direction and angle. Raise the launch rod to the desired height. By varying the launch rod height, which is calibrated in centimeters, you can control the distance of the rocket's flight. To launch, release the launch rod so that it falls to the bottom of the cylinder. This action compresses the volume of air in the cylinder and forces it out the launch tube, blasting the rocket away. When rockets are launched, simply release or drop the launch rod. Avoid forcing the rod into the cylinder. Teachers, we've included eye protection in your kits for students to wear while rockets are being launched. Go ahead and give each student a data sheet. Allow them to have time to discuss and answer the 2 questions on their data sheet. Also, you'll want to take a moment to remind students what their jobs are when they're launching, and remember that each student should launch 3 times. As we're paused, we'll leave a few reminders on the screen for you while you're launching. Before launching a straw rocket, clear all people from the rocket's flight path. When launching the rockets, the launch rod simply needs to be released or dropped. Avoid forcing the rod into the cylinder. The straw should fit over the tube and be able to slide freely up and down. If the straw is too loose, air will leak between the straw and the tube. decreasing the distance the rocket will travel. Launches need to be performed on a smooth, flat surface, like the floor. How did that go? Did your rockets generally fly straight? If not, do you know what adjustments you need to make? Do you remember what the important parts of a rocket are? Can you explain what makes a rocket fly? What is a force? And how do fins work? Remember, as you were building your rockets, we talked about other variables. Trying other shapes and weights for your nose cones, trying other shapes for your fins, trying different numbers of fins. If you continue testing your rockets, you might want to try some of these variables. Teachers, if you're interested, we have a second lesson using straw rockets that tests even more variables. You all did a great job today. Thanks for joining me. And teachers, thank you for using this WOW lesson. Please check out more at our website at wpafbstem.com.